Alright, this video is going to talk about long division of polynomials. Before we get to the steps of long division for polynomials though, let's remind ourselves how we do long division with numbers, because the process is really similar so that we can apply it and it'll help us remember what to do. So on this example up here, we're trying to divide 7 into 843. So pretend you're back in 4th or 5th or whatever grade it was you learned long division. 7 goes into 8 one time. So we write it up above, and then we say, well, 7 times 1 is 7. So we subtract 7. 8 minus 7 is 1. Then we bring down the next number. We say, how many times does 7 go into 14? It goes twice. So 7 times 2 is 14, and then we subtract. That subtracting thing is really important, and that's going to be, and then bringing down the next term. Those are two of the biggest things that are going to be related. How many times does 7 go into 3? None, but we still have another place that we need something, so we put 0. You don't have to do minus 0 if you don't want to. We have a remainder of 3. When you first started doing long division, you would put like R3. There's two other ways of doing it. We could go on and get a decimal, or we could just write this as a mixed number and say that this is 120 3/7, which that's what we're going to do with our polynomials, is write it as a fraction. So the reason we divide polynomials, or one of the reasons, is it can help us to solve equations and help us know if something's a factor of something else. So on this example, it says, is x minus 6 a factor of x squared minus x minus 30? Well, that's really easy actually to tell whether it is or not, because you can simply factor x squared minus x minus 30 into two parentheses and see if x minus 6 really is a factor. But a way that we could prove that it was a factor is by dividing them and seeing if it divides evenly, because that's what it means to be a factor. So here's how we do long division. The thing we're dividing goes on the outside, and what we're dividing into goes on the inside, like so. Then we look at the first term here and the first term here, and we say, how do I get from an x to an x squared? What do I have to multiply by? And if it helps, you can think of it like it's a division problem. X squared divided by x is just x. So to get from x to x squared is x. I'm going to write that above this other x, because that's going to let me keep track of how many more steps I have to go. Because if my first thing is an x, then my next thing is going to be a number, and then after that all I have left is possibly a remainder. The next thing, and this is where people get tripped up, I only look at this first term to figure out what to put up here, but then I have to multiply both things by that x, and I write it underneath the x squared minus x up here. So this is x squared minus 6x. But just like whenever we do long division with numbers, I actually need to subtract that. And so when I subtract x squared minus 6x, that's going to cancel the x squareds out. But when I subtract negative 6x, that's really like adding 6x. So negative x plus 6x is 5x. And then I drop down the negative 30 and start the process over again. I say, what do I multiply x by to get 5x? And so that's going to be a 5, a positive 5. And then I multiply the 5 into the x and the minus 6. So that gives me 5x minus 30. But I subtract that, and so that gives me 0, and so I don't have a remainder. So yes, this really is a factor of what we started with. Alright, we're going to do another long division problem. On this one, they tried to trick us though, because if you look on top of this fraction, we're not in standard form, and that's a really important thing we need to do, is be in standard form before we divide. So the w plus 3 is fine. If it had been switched around, we would want to, like if it said 3 plus w, we would want to rewrite it as w plus 3. When we write the top in standard form, I want the biggest exponent first. So I'm going to do 3w cubed plus 7w squared minus 4w plus 3. So this is going to work out like really similarly to what we did on the last problem. We're going to look at the w and the 3w cubed and say, how do I get from w to 3w cubed? So I need a 3w squared. So I'm going to write that on top. And what I need to do is multiply w plus 3 by 3w squared and write it underneath. So that's 3w cubed plus 9w squared, but we're going to subtract that. So that's going to be 7w squared minus 9w squared, which is negative 2w squared. Then we drop down the next term, and we start over. So we want to say, what do I multiply w by to get negative 2w squared, which is negative 2w. So I write it up here at the top. And then I multiply w plus 3 by negative 2w, which gives me negative 2w squared minus 6w. But we want to subtract that. And so if it helps change these signs, what we're really doing is adding 2w squared and adding 6w, which makes 2w. Drop down the plus 3. Then we start over. What do I multiply w by to get 2w, which is 2. And then I do w plus 3 times 2, so that's 2w plus 6. And if you weren't careful, you might have thought that this didn't have a remainder, but since I had to times by 2, that's why that ends up being a remainder of negative 3, because it's 3 minus 6. So I'm going to write minus, and then I do 3 over what I'm dividing by, which is w plus 3. So this is my answer. This last example looks weird because of this 2p minus 3 to the negative first. If you remember what negative powers do is we typically just write what it is on the bottom and give it a positive exponent. So this is really asking us to do the same thing. It wants us to divide by 2p minus 3. So the trick on this one, aside from that, is that we're actually missing a p to the fourth up here. So we'll have to put that in as a placeholder. So now we're going to set up the problem and work through it. So I'm dividing by 2 pi minus 3, and then into 4p to the fourth plus, oh, that's supposed to be cubed as a placeholder. I had a p to the fourth, I didn't have a p cubed. Plus 0p cubed minus 17p squared plus 14p minus 3. So this is just like the other ones were, so you might try to pause it and see how far you can get without me, and then let me catch up to see how you're doing. We need to know, what do I multiply 2p by to get 4p to the fourth, which would be 2p cubed. So I multiply and get 4p to the fourth minus 6p cubed, and I'm going to subtract those. So that means that this is really a positive 6p cubed for my next step. Then I drop down the negative 17p squared. Then I say, what do I multiply 2p by to get 6p cubed, which will be 3p squared. So I multiply both of those and then subtract. So that's really going to be like a plus 9p squared, giving me negative 8p squared. Drop down the next term. So what do I multiply 2p by to get negative 8p squared, which is negative 4p. And then I multiply. And then I subtract. So that's really 14p minus 12p, which is 2p. Drop down the negative 3. Now at this point, you might notice that this goes in evenly. Make sure you put the plus 1 up here, and then it does leave us without a remainder, and so we don't need to put a fraction at all.